Hello, I'm Aaron Zimmerman. In our last adventure, we dove into the world of Python to craft a text-based game of Tic-Tac-Toe powered by ChatGPT. Click the link if you missed that video. Don't forget to click that like button, comment, and subscribe to stay up to date on all our programming and logic explorations. Part 1. Propositional Logic Basics. To kick things off, let's get used to the language of propositional logic. If you Google propositional logic online, the second link is a logic calculator. Think of propositional logic as the DNA of logical reasoning. It's about making sense of statements that can either be true or false. Those statements are labeled as letters, as we can see here, with PQR through EGH. I encourage you all to get hands-on experience with this logical calculator. Click examples and information on the syntax for more. The symbol that almost looks like an A is the AND symbol. Upside down to that is the OR, and this is NOT. The arrow right means if. Arrow left and right means if and only if. We can make a simple logical expression that is not P and Q or R, and click execute to see what the results are. Since what we made was a logical formula, any true or false value can be given for P, Q, and R. So those given values are displayed on table left, and the results are displayed on table right, where 1 means true and 0 means false. The truth value with an asterisk beside it is the result of the formula. So because we used an OR, there only needs to be one truth here or here. So anytime the R is true, the overall result is surely true. And because we used an AND, both of these values need to be true for the left of the OR to be true. Because this P is negated, we can see that when we are given a 1 for P, there is a 0 for the left of this AND. And when there is a 0 for P, there is a 1. And these are the only two times where both not P and Q are true. And so the answer is always R, except this one example. Then we can click back to the form to do more logic. I hope that you're finding this to all be very intuitive because it's based off of language. Part 2. Conjunctive Normal Form, or CNF. CNF is a way of structuring propositional logic so that it's optimized for computer processing. All we have to do to convert propositional logic to CNF logic is remove all ifs and if and only ifs. P if Q is identical to Q or not P. And P if and only if Q is identical to P and Q or not P and not Q. In the logical calculator, I've put the propositional form P if Q and ORed it with the CNF form Q or not P, and the results on either side of this OR should be the same. Let's execute and see. We can see that the if statement P if Q is always identical with the result of the formula. And if there is at least one true in the OR statement over here, then this evaluates to be true, which is identical again with the result of the formula. Now, let's do the same with if and only if. The order of operation in CNF is that first we apply the nots to each statement, then we apply the ands to those, and finally we apply the ors. So no parentheses are needed, but I'm using parentheses here to be more clear. So intuitively, we can think of CNF as a bunch of logical formulas that are all ORed together. We're hoping to find one of those logical formulas to be true, and each of those logical formulas are just ands together of statements that may or may not be negated. This is the conversion of P if and only if Q, where in CNF it's P and Q or not P and not Q. Let's execute this and see if the left of the OR is the same as the right. Again, we can see the if and only if is always the same as the resulting truth value. And the column under this OR symbol is the result of the CNF. Feel free to pause the video to take a closer look at this table. Part 3. Applying logic to tic-tac-toe. Imagine you're playing tic-tac-toe and you want to develop a strategy using logic. First, when applying logic, we need to figure out what statements we're working with. So in tic-tac-toe, we'll use these coordinates and these statements. So if there's an X at 0, 0, the top left cell, then we'll use the code X, 0, 0. If there's an X in the middle of the tic-tac-toe board, we'll use X, 1, 1. And we want to figure out how to win the game, so we'll use X, 0, 0 asterisk if playing an X at the cell 0, 0 will win the game. If playing X at cell 0, 0 helps win the game, then that statement will be labeled as X, 0, 0 plus. If X, 0, 0 plus is true, then playing X at cell 0, 0 must help win the game. So we can start to encode the logic with X, 0, 0 asterisk if X, 1, 0 and X, 2, 0. So that means X at 0, 0 will win the game if there is an X at 1, 0 and 2, 0. And to convert that to CNF, X, 0, 0 star and X, 1, 0 and X, 2, 0. So since these are ANDed together, if there isn't an X at 1, 0 or 2, 0, then this would all evaluate to be false. And more comprehensively, there are 3 ways where playing X at 0, 0 could win the game. If it completes a row, this will evaluate to be true. If it completes a column, this will evaluate to be true. And if it completes a diagonal, this will evaluate to be true. And these are all ORed together, so if any one of those evaluate to be true, then playing X at 0, 0 will win the game. So in our program, we will iterate through all cells and ask, will this cell win me the game? Will this cell win me the game? Will this cell win me the game? And so on. Conclusion. Remember, this is only the beginning. In our upcoming videos, we will be coding these principles into our Python tic-tac-toe game with and without artificial neural networks. If you're excited about coding these logical principles into tic-tac-toe, drop a comment below and share your thoughts. Make sure you hit that subscribe button and turn on notifications so you don't miss out on our next installment in this series. Thanks for watching, and I'll see you in the next one.